Hello friends, welcome to online lecture series of discrete mathematics. So in last lecture we have studied the mathematical induction. So here today we will continue this mathematical induction. Whatever examples based on this mathematical induction. So next example. So prove 5 raised to n. So prove 5 raised to n minus 1 is divisible by 4. For n is greater than or equal to 1. For n is greater than or equal to 1. So here you have to remember one thing here. Whatever n is given. So here for this example, 5 raised to n minus 1 is divisible by 4. For n is greater than or equal to 1. If n is greater than or equal to 1, then we start with n is equal to 1. Right? Whenever n is greater than 1, then we have to start with n is equal to, by putting n is equal to 2. Right? Okay. So here we have to prove 5 raised to n minus 1 is divisible by 4. So first, what is your statement? S of n, that is 5 raised to n is divisible by 4 is first statement. So first, basis of induction. First step is a basis of induction. So put n is equal to 1. So after putting n is equal to 1, S of 1, right? That is 5 raised to 1 minus 1, that is equal to 4. So this 4 is divisible by 4. Yes, this 4 is divisible by 4. So we can say that this S of n is true for n is equal to 1. For n is equal to 1. Then second step, basis of, induction hypothesis. So for induction hypothesis, here assume, right? Assume that this S of n is true for n is equal to k. N is equal to k. Means here put n equal to k. Right? So S of k. So what is S of k? S of k, that is 5 raised to k minus 1 is divisible by 4. Here we assume that that statement is true. Next, induction step. So in induction step, 5, here put n is equal to k plus 1. Means here we have to prove that n is equal to k plus 1 is true for, S of k plus 1 is true for n equal to k plus 1. So here 5 raised to k plus 1 minus 1. We have to put n is equal to k plus 1 equal to. So you have to make some adjustment here. So what is this 5 raised to k plus 1? So 5 raised to k plus 1, right? So we can write like this: 5 raised to k into 5 raised to 1. The meaning is same, that is 5 raised to k plus 1. So here 5 raised to k plus 1 minus 1 is equal to 5 raised to k into 5 minus 1. So what is a minus 1? So we have to make some adjustment here again. So minus 1 is, so here minus 5 plus 4. So minus 5 plus 4, so meaning is same, that is minus 1. So 5 raised to k into 5 minus 5 plus 4. So here this 5 gets common. So 5 raised to k minus 1 plus 4. So by induction hypothesis, right? So by induction hypothesis, what is induction hypothesis? So this 5 raised to k minus 1 is divisible by 4. Already assume that this is divisible by 4. So this 5 raised to k minus 1 is divisible by 4, right? And this 5 is multiple of this, means this whole term is divisible by 4. And this 4 is also divisible by 4. So we can say that this S of n is true for k n is equal to k plus 1. So by induction hypothesis and by divisibility, right? This we can prove that this 5 raised to n minus 1 is divisible by 4 for n is greater than or equal to 1. So next example, prove that by mathematic induction 8 raised to n minus 3 raised to n is multiple of 5. Multiple of 5 where n is greater than or equal to 1. So again same here, s of n is equal to 8 raised to n minus 3 raised to n is multiple of 5. So first step, basis of induction. So put n is equal to 1. So s of 1, that is 8 raised to n minus 3 raised to 1, that is equal to 5. So 5 is a multiple of 5. Yes, 5 is multiple of 5. So s of n is true for n is equal to 1. Then second, induction hypothesis. So induction hypothesis, assume s of k is true. S of k is 2. So put n is equal to k. So s of k is 8 raised to k minus 3 raised to k is multiple of 5. So we assume that 8 raised to k minus 3 raised to k is multiple of 5. Then third step, induction step. Then in the induction step here, you have to put n is equal to k plus 1. Right? So s of k plus 1, that is 8 raised to k plus 1 minus 3 raised to k plus 1. So again 8 raised to k plus 1 means what? 8 raised to k into 8 minus 3 raised to k plus 1 is 3 raised to k into 3. So here we make some adjustment here again. 8 raised to k into 8 minus 3 raised to k. So we make adjustment for this 3. That is 8 minus 5 is nothing but the 3. So 8 raised to k into 8 minus 3 raised to k into 8 plus 3 raised to k into 5. Right? So here 8 gets common. So 8 into 8 raised to k minus 3 raised to k plus 3 raised to k into 5. So this term, this last term is multiple of 5. Yes. Then this one by your second step, that is induction hypothesis. This term 8 raised to k minus 3 raised to k is divisible by 3, is a multiple of 5. Right? So this whole term is a multiple of 5 or divisible by 5. Right? So you can say that 8 raised to n minus 3 raised to n is a multiple of 5 for n is greater than or equal to 1. So we stop here. This is the end of your mathematical induction.